Okay, taking a look at area and volume, you can see that I included a little 2 and a little baby 3, meaning that area is going to have 2 dimensions, a length and a width. Volume is going to have a length, width, and height, making it 3-dimensional. Area is going to cover triangles, rectangles and parallelograms, and trapezoids. I'm going to try and break down how the formulas are created, so it makes it seem a little bit better, but I think the pictures are going to help. And then finding volume of a rectangular prism. Capital B and a lowercase b means something different, so it's important that we're recognizing that when we're going through it. A review of triangles, anytime you're taking half of something, you're cutting it in half, is what you told me, is dividing it by 2. And we know that we can find the base and the height just from the right angle. So locate the right angle. That makes an H, and it also makes a B. You can also think of the chair. So I'm just going to go ahead and highlight all of those, and we can determine a base and a height for all this stuff. So if this triangle were 8 by 10, and the only reason I know that the height is 8 is because of the H that this forms, or how tall the chair was. I also know that the chair is sitting on this side. So that would be my base. I prefer to go ahead and write B equals and H equals just to be thorough, so that way I'm not mixing up any of my pieces. So base is 10, height is 8. The formula is 1/2 base times height, or anything divided by 2 is the same thing as multiplying by a half. So 10 times 8 divided by 2, 80 divided by 2. You have an area of 40 square units, or 40 units squared, either or. To take a look at the one in the middle, I wanted to include a scalene triangle, an equilateral triangle, and an isosceles triangle, just because they look different whenever you're trying to find the area of them. So for the equilateral in the middle, let's do 5 and 6. So base is where the chair sits, or where it makes the B. So 6, and the height is 5. How tall the chair is, or where it makes the H. 5. So 6 times 5 divided by 2, 30 divided by 2. Area is 15 square units. And keep in mind, all of these came from the quadrilateral, that we would find the area by base times height, and then we cut them in half. So this one was almost a rhombus. It was more of a parallelogram. The first one we did, the the scalene, was a parallelogram. And it looks like all these are coming from parallelograms. So let's go ahead and find the area of the third triangle. Let's do 4 and 4. So just to emphasize the base and height, this is the only part that's difficult. The H, how tall the H is going to be your height. And where the B sits, or where the chair legs sit, is going to be your base. Base equals 4. So 4 times 4 divided by 2, 16 divided by 2. Area is 8 square units. That's a review of triangles. To move on to rectangles and parallelograms, it's taking that 1/2 step away, taking the dividing by 2 away, and really the way to identify base and height is the exact same. So, I mean, you could do that on any of these right angles, because you can do base and height interchangeably when it comes to a quadrilateral, except for when it comes to a parallelogram or a trapezoid. So, I mean, if we have a 5 by 10, and you want to identify the base as 10 and the height as 5, I'm just going to go ahead and flip those around, because if we had this rotated to where it was standing up on this side, then we'd end up having a base of 5 and a height of 10. Now, the only reason I'm doing this is I just want to show you that the base times the height, it doesn't matter whenever you're talking about a rectangle or a square. It's still going to be 10 times 5, and you're going to get 50. and the other one's going to be 5 times 10, and it's still going to be 50. So when we're talking about, I mean, what does it matter what the base and height is? It doesn't until you get to a parallelogram or a trapezoid or a triangle. So anytime you see 4 right angles and you only see one angle or one side measure, like 5, that would mean it's a square. So we can make all the sides 5. Remember, use the B and the H. There's H, or there's B, and there's H. So 5 times 5, base times height. Base is 5, height's 5. 25 square units, base times height. And all of these, when they're cut in half, make the triangles that we just did, which is makes all this divided by 2, which makes all of this divided by 2. The same thing's going to happen with the parallelogram. Still going to look at the right angle. It looks like a backwards B now, so a lowercase d and a backwards h. But you get the idea. You can think of it as a chair. That makes more sense. So 10 and 20. Area is still base times height. So the base is where the chair sits, so 10, and the height is 20. How tall the chair is. Still base times height, so 10 times 20, 200 square units. The triangle of this, which looks like it would be a scalene, would be 100 because you have 100 here and 100 here. So combined they have 200. So that's rectangles and parallelograms, pretty simple. Trapezoid is confusing, I'm not going to lie. So whenever we're looking at a trapezoid, basically what happens is you're taking a chunk and rotating it. So this also originated from a quadrilateral, just like all the other stuff did, like a triangle, a parallelogram. You're basically just taking the chunks, and this is the original quadrilateral that it was, approximately. So like you can see that this is going to be a rectangle, so this would be base times height. But since we end up having this chunk and this chunk flipped inward, then we end up with a trapezoid. And what this B1, B2 is, B1, B2, adding them up and then dividing by 2 is taking the average. So if the top of this one were 10, that would mean the bottom of this one were 10. So 10 plus 10 is 20, divided by 2 is 10. So that means the average width or the average base of a rectangle would be 10. And then whenever you cut it up, this one would end up being like 14, and this one would end up being 8. So anytime that you want to add up a base and a base, so 8 plus 14 would be 22. 22 divided by 2 would mean that it was originally a rectangle that was 11 as the base on both sides. So it's finding the average. So base 1, base 2, and you know this because it's where the height connects, the top and the bottom of it. So I'm going to go ahead and stick with the 8 and 14, and I'm going to make it 5 tall. And again, the only time that you would be looking for these sides is when you're finding the perimeter of a trapezoid, and I really don't think that you're going to be doing that, so that's not a big deal. So the way the formula looks is kind of confusing. Is you have base 1, which we had 8, plus. Remember, anything multiplied by a half is the same thing as dividing it by 2. So base 1 was 8, base 2 was 14. The height was 5. So a number next to parentheses or a number next to a letter or a variable means to multiply. And since we're multiplying by a half, we're going to divide it by 2. So 8 plus 14 is 22 times 5 divided by 2. Okay, and then you should have, let's do 22 times 5. 110 divided by 2 equals 55 square units. That process looks like it takes a lot, but really it's only adding up the two bases, and then it's the same exact thing as base times height. And then you divide by 2. So you're kind of treating it like a quadrilateral that's a triangle. Add these two, multiply by the height, divide by 2. I'm going to provide some extra practice on that, and then we'll go through it during tutorials as well. For the last thing, rectangular prisms. This is kind of confusing because when you start getting to triangular prisms next year, you're going to start seeing how the base actually does matter. The most important thing in this formula is capital B, and understanding that means area of the base. So, I'm going to go ahead and choose this bottom side as the base on this one, and on the middle one, I'm going to choose the front side, and on the last one, I'm going to choose the right side. So, I'm going to just show you that it doesn't matter which side you choose as your base for a rectangular prism. So 8 by 5 by 3. So when it says area of the base, that looks like it's a rectangle to me, the one I shaded in blue. So the area of a rectangle is length times width. So 8 times 5. And what this ends up being is just length times width times height for every single rectangular prism or cube. You'll see because it's going to be 8 times 5 times the height, which is 3. There's only 3 numbers there, and we multiplied all 3 of them, so that's volume. So 40 times 3 should be 120. 120 cubes fit inside of there. So inside of this box, a whole bunch of little tiny boxes fit in there, and there's 120 of them. Depending on the unit measure, if we're talking about centimeters, then it would be cubic centimeters. Centimeters, 1 centimeter by 1 centimeter by 1 centimeter. Like a dice. On middle one, if you had like a 2 by 10 and the depth of the prism was, let's say, 4, you're going to see here that, all right, we have to find the area of the base. Again, it's a rectangle, so area is length times width. That's going to be 10 and 2. It's 10 long and it's 2 wide. So you're going to see here that it's going to be length times width times height again. 10 times 2 times 4. It doesn't matter which order you multiply those in either. So volume is going to be 20 times 4, which is 80 cubic units. For the last one, the process is the same. I'm going to go ahead and just make it a cube so I can show you that just because it's a square, squares are already rectangles. So that's why it's still called a rectangular prism, but there's a specific name for it when it's all squares, and it's a cube. Let's use 3 by 3 by 3. So side squared or side times side or length times width, either way it's going to be 3 times 3. That's going to be the length and width of this base on the right side. So area equals length times width. You do area equals side squared. You could do area equals side times side. All that stuff means the same thing. So that's going to be 3 times 3 for the area of the base times the height, which is the distance between bases. If you want to do that, bases are always parallel with each other. So it's going to be 3 times 3 is 9 times 3 is 27 cubic units. These are just examples to try and get the basics down and for you to have it as a reference. I'm going to put times in the description, so if you want to skip to like a rectangular prism, you can skip to it instead of watching the whole thing and trying to guess where it's at. Try the practice that is provided with this, and it's going to follow along with the video in the order that it was presented, so that way it'll be easier to find.